Alright, so sorry about the wait. I'm going to keep going with Form B, so same one from last week, and we'll finish off the day. So we've got 3 problems left. I'm going to be doing 4, and then the homework is 5 and 6. So we're dealing with a rate of change again, this time integrating and deriving and interpreting what it means in terms of our velocity at any time. So I have a squirrel that's starting at building A at time t equals 0, traveling along this straight wire connected to another building. For t is 0 to 18. I want to know the squirrel's velocity as modeled by this piecewise linear function defined by this graph. First, what times would the squirrel change direction? And how would you know?
So the velocity versus time graph, right? Yeah,
Yes.
also at t equals 9 and 15, it changes direction, because at t equals t and 17, the velocity is 0, which means stop. And it changes sign from positive to negative.
There we go. Okay, so as the velocity is 0 and changes sign, about these points. Okay, that was good. Part B.
Fastest from building A. So fastest is when it has high velocity.
Sorry, this is not fastest, this is the farthest.
Oh, farthest, which means total area is the biggest. So at t equals 9, it is the farthest from building A.
Okay, and we're gonna have to prove it.
Because the area under the graph shows that the total distance.
Okay, total distance from building A. What's the distance at t equals 0, though?
T equals 0 is 0, right?
Yes.
Yeah.
Because we started at building A. Okay.
Yeah.
And then I'm gonna have breakpoints where?
9 and 15 maybe.
Okay, 9, 15, and then at the endpoint as well. So 18. So we'll need to test all 4 of those. And then give us the area. Okay, so what's my what's your displacement at t equals 9?
Equals 9 is 9 plus 5. 14 times 20. No, it's 140. Yeah, 140 is the answer.
Okay.
And 15 is 140 minus, that's 9 to 15, which is 6. 6 plus 4, 10 divided by 2. 5 times 10 minus 15, so 90.
Okay, so 90. Okay, we're good so far. 140, and this was minus 50.
That 15 to 18 is 3 plus 2, 5 times 10, 50, 25.
So what's the displacement?
24 115.
There we go, 115. Okay, 115. Okay, so what can we conclude?
So therefore, at t equals 9, it is farthest from building A.
Okay, and then why did we pick t equals 0, 9, and 15 again?
Because at that time, it changes sign.
Okay. So I could say something like the velocity is 0 at t equals 0, t equals 9. And t equals 15. Okay, that should be good. Then part C.
Find the total distance from 0 to 18. Oh, we just add. No, we have it in B.
Okay, so
No, never mind. Yeah, we have it actually.
we have 140, negative 50, and 25.
We just add all the numbers. No, yeah, we just add it. But minus should be positive.
Okay, so how could I write that? My distance.
It's integration.
Distance at t equals 18. Should be equal to the
Is
integral.
integral absolute value of velocity 0 to 12. No, 0 to 18.
One more thing.
dt.
dt. Okay, and then what is that equal to?
That is equal to total distance. Oh, 140 plus 80 plus 25. Oh no, 50 plus 25.
Okay.
So that's 215.
215, awesome. Okay, and last ones.
Write the expression, acceleration, velocity, and velocity from 7 to 10.
Mm-hmm.
We only have like velocity at 7 and 10. But distance. Oh wait, no.
So we need 3 separate equations. One for acceleration, one for velocity, and one for distance. That will give us the acceleration, velocity, and distance at that interval.
Acceleration will be the slope.
Okay.
So f 10 minus f 7 over 3.
Okay, I'm gonna subscript this maybe. So let's say. Oh, there we go. for our interval, 7 is less than t is less than 10. And the acceleration at any time you said was, say again?
F10 minus F7 over 3.
Okay, I don't have any f's, so how can I have subscript?
F prime, no, V prime T.
Okay, I can do that. Hold on.
Oh!
Okay, you're on the right track, but I don't have any f's, so this would be
Oh! V10 minus V7.
there we go. Over
3.
okay, what's V10?
V10 is minus 10.
Okay.
Minus 10 minus... wait. 20 over 3, so minus 10.
Okay, so that's acceleration. Then we need an equation for our velocity.
But we only have like velocity is same as velocity.
That's true, but I need an equation that I could plug t into in order to get the velocity at any time.
Maybe x20, x10 minus x7.
This function is a line, so you should be able to create an equation of that line that's showing on the graph.
I don't know how to VT. Oh, it's just the point of the graph. Should we say like that?
Why don't you start with point slope form and we'll figure out an equation from there maybe? In point slope form, what would the equation of a line be? What's the equation of a tangent line?
Y minus fx is equal to f prime x times x minus a.
Okay. So this is your equation of a, this is what we call point slope form. We can do that to write the equation of any line if you want. So as long as you know what the slope is along this line, you should be able to plug in any point that you want, A, B, right? Okay, so I'm going to rewrite that equation, but using your variables for velocity instead. So what would this become?
So y minus x.
Okay, our
No,
y value is
yeah,
velocity. So this is your velocity at any time, minus, pick a point.
7 and 10.
That's
No, maybe 7.
Okay, so if t is 7, what is your velocity?
20.
20. Okay, so this should be in point slope form. So this is y, that's vt, minus...
Wait, why did it stop? It stopped to me.
Your picture's frozen, you mean?
Yeah.
Okay, let me send this last question in the chat. And I'll do that on Skype and WeChat. Okay, so you should have it in the Skype chat and in the WeChat in just a minute.
Mm-hmm.
Okay, that's what we've got so far. So we are writing the equation of this line in point slope form. So you said our general form is something like y minus b equals f prime a times x minus a. In order to do that, you need a general form y and x. So for us, that's vt and t, and a point ab, and then we'll plug in to write an equation. So you picked the point 720. So this is yt minus what?
Yt minus x.
Okay, so this should be y minus b. What's your b right now?
7.
7 is an x value.
Oh, 20.
Okay, so this is, for us, our y is vt, so that's velocity minus 20, is equal to what?
Acceleration at t equals 7.
Acceleration from t equals 7 to t equals 10, so for the whole interval. What's the acceleration?
Minus 10.
Minus 10 times your x value, which
10
is...
minus x minus 10. X minus 7.
Okay, and x is t, so this is t minus 7. Okay, so we're going to solve for vt, and then we're done.
Oh.
So our velocity at any time is going to be equal to, on the right side, that'll become negative 10t minus negative 70, or 10t, negative 10t, plus 70 plus the 20 is plus 90.
Yes.
Okay, that's it for velocity. And then we need another equation for the distance at any time.
So displacement is integration from 7 to 10.
Okay, we'll start there. So integral from 7 to 10 of
Vt.
vt, which we just found an equation for. So that's the integral from 7 to 10 of negative...
Minus 10
Yeah.
t plus 90.
Plus 90 dt. Okay, and I'm not quite done because we do have a start point for that interval. What was our velocity at 7?
So minus 5t squared plus 70t integration 10 to... Wait, but we have to write an expression, right?
Yes.
Not the answer. Oh, dt. But we have to simplify.
So right now this is how much our velocity changed from 7 to 10. But if I want the total distance from building A, we already had some distance at t equals 7.
Oh yeah, so we have to have t equals 7.
How much distance did I have at t equals 7?
It's area. So 5 plus 7, 12 times 20, 22, 40, 120.
120, perfect. Okay, so this is... I'm going to write x at 7 and then I'll come back in and simplify. In fact, I'm going to write my general form here all the way, and then I'll come back and simplify for next time. So this is x at 7 plus the integral from 7 to 10 of our velocity in terms of time, which is the same thing as x at 7 you told me was 120, which is right, plus the integral from 7 to 10 of negative 10t plus 90 in terms of time. Okay, we can actually solve that, I think. We could simplify at least. What happens when I integrate negative 10t plus 90 from 7 to 10?
So minus 5t squared
Okay,
plus 90t, and then we plug in 10 and 7.
okay, so I've got 120 plus negative 5t squared plus 90t from 7 to 10. Okay, so I'm going to plug in 10, subtract what happens when I plug in 7, and then add 120 to everything. So that's 120 plus... 120 plus... if I plug in the 10, what's going to happen?
Minus 500 plus 900 minus 49 times 5.
Okay.
245.
Okay, I've actually made a mistake here. I think maybe we both have. My upper bound is not 10. What should my upper bound be?
Just any time?
Anytime. There we go. Just realized we're creating a general form, not just the displacement. Okay, so if this is upper bound as t, then when I go to substitute in, this upper bound is negative 5t squared plus 90t, and then I'm going to subtract my lower bound. What's my lower bound?
49. 245 minus 245 plus 630.
Okay. That's... Okay, I've got a different answer, so hold on. Okay, so I've got negative 5 by 49. So that would be half of 490 is negative 245 plus 90 times 7. 630. Okay. So I've got, for my constant, positive 245 minus 630 plus 120. or negative 5t squared plus 90t minus 265.
Mm-hmm.
Okay, cool. Any questions on what we did?
No, last part was kind of tricky.
A little bit. It was a little bit weird just because we were creating general forms for only that piece.
Mm-hmm.
But I think it's doable. Can you see the video right now or not?
Yeah, I can see.
Okay, cool. I'm going to go ahead and save that last slide because that was the only one we had trouble with, and send that through. And then once again, homework for the weekend is to finish off the rest of these free response questions for that year. So I will resend the entire document over. I'm also not missing any grades for you for both physics and calculus, so you're okay for the quarter.
Yeah.
I have not finished grading the rest of this week yet, but I can let you know what your quarter grade looks like as soon as I finish that at some point this weekend. Okay, so that file's coming through on WeChat, and I'm just getting this through Skype now. Okay, and that's over on both. That should be it. Is there anything else you want to talk about?
No, but when we go back.
I think I lost you for a minute there. You said something about going back?
Yeah. When can we go back to school? About?
Still don't know yet. So once Miss Martinez tells us, then we'll have 3 weeks notice.
Mm-hmm.
So, if the government says tomorrow everybody goes back to school, then that starts a timer, and 3 weeks after that, we'll go back to school.
Oh, 3 weeks at least from today.
Yep. So until they announce, we at
Okay.
least have 3 weeks left. But I'm
Alright.
sure as soon as they announce, Miss Martinez will be all over it, and you'll see announcements all over WeChat and email and GradeLink and everywhere.
Mm-hmm.
Okay. So thank you very much, and I hope you have a good weekend.
Have a good weekend.